Hey everyone, my name is Ankita Sood. I'll be your host today for this very first and very exciting session webinar series with Brian and Mike. And I'll just let you all take over. But before we get started, I'll just share our code of conduct. Please adhere to it, otherwise, there will be consequences. And if you all have any questions, definitely drop them in the Q&A section that you see down below. And Mike and Ryan would be addressing them. Mike and Brian would be addressing them at the end of the session, but definitely as you think of questions, keep sharing them and we will most likely cover all of them and have you all taken care of. All right, I'm super excited. You would think this is not a cooking show in case you were misled by the name. But
Uh,
take it away, Brian.
yeah, sure. We're just so thrilled to be here. Yeah, so we're going to be talking today about Hashbrown. And so to kick things off, we really just wanted to get people kind of thinking about how AI is transforming the way we work. So I don't know about you, but the way I work today is much different than maybe I worked even a year or 2 years ago. GitHub Copilot is really providing a lot of solutions around code completion. ChatGPT is helping me answer questions. I can ask technical questions and I get direction. I can even have ChatGPT write code and integrate that right into my editor. And the developer tooling is really changing. I'm not sure if anybody here is using things like Copilot or ChatGPT in their workflow. If you are, go ahead and drop that in the chat and just let us know. Would be interested in seeing kind of what type of developer tooling are you using. Recently, I've really been enjoying Cursor AI and all of the agentic workflows that it provides. And so LLMs are continuing to really gain in intelligence. And we really think that there's an opportunity here. Because as Angular developers, certainly AI is transforming the way we work and the way we develop. But we think that AI can have a really big impact in the way that we also develop and build applications. And so that got me and Mike thinking, like, what if we could start to build intelligence into our actual Angular applications today?
Yeah. So as Brian's mentioned, AI has completely changed the way that we're building apps, but could AI also change the way that users interact with apps? Like I just get a big smile on my face whenever I'm using my IDE and the right completion appears and I can just hit tab to accept it. Or recently I've been playing with Git or OpenAI's Codex CLI and its ability to
Mhm.
let me do large scale refactors. Like it just brings me a lot of joy how much faster I'm able to work. And so we've been wondering, what if we took this idea of enablement that AI is bringing to developers, and instead of making development faster, what if we made our users faster as they used our app? What would it look like if we built Angular apps
Mm.
with intelligence built right into the user experience? But before we start answering that question, a quick set of introductions. First, I'm Mike Ryan. I'm one of the co-founders of LiveLive I'm also a Google developer expert in Angular and web technologies, and you probably know me from my open source work. I am one of the co-creators of NGRX, the de facto state management for Angular.
Yeah, and my name is Brian Love, also a co-founder here at Love App and a Google developer expert in Angular and web technologies. And just really have enjoyed being a part of the Angular community over the last 5, 10 years, contributing in many ways and speaking at conferences. And we're really excited to bring something new to you today.
And if you ever want to work with us, you can reach out to us at liveliveapp.com. We help developers find absolute joy in building and delivering web applications. We are very interested in exploring what it means to explore data on the web using AI. So feel free to reach out to us again, liveliveapp.com if you want to learn more about that. But everything we're going to show you today is completely free and open source. So we are exploring this idea of building generative user interfaces in Angular. And this is kind of a new term that Brian and I have been
Mhm.
working with. And the idea is, we have generative AI. And with generative AI, when you're using ChatGPT, we can see the AI generate things like text, or maybe you put on advanced voice mode and the AI is generating speech. It can generate images with Dolly. And the idea with generative user interfaces is that it builds on top of this concept where we're using AI not to generate text or audio or images, but instead using the AI to generate user interfaces on demand on the fly. And to explore this concept, we have built an open source project that we call Hashbrown. Hashbrown is a framework for building joyful generative user interfaces. It has support for both Angular and React, though today we'll be focusing on Angular. I like to think of this as being an Angular first framework. And we support large language models from vendors like OpenAI, Google, and Writer, along with OpenAI's models via Azure.
And Hashbrown is completely open source. And so we are committed to delivering Hashbrown. You can go check it out on GitHub. You can file a PR. You can see all the code that we're contributing to the repo. And so that means that it's free, it's open source, and it's MIT licensed. So go check it out. And we've got a link here as well.
Yeah.
We're also looking for contributors to come join us along the way. So as you can see, it's not just the Live Love app team. We also have external contributors today, and we're really excited to bring on more contributors and people to kind of come join us on this journey as we just kind of explore and start building generative UI in the front end.
So how does Hashbrown work? Well, first off, you're going to bring your own backend when you're using Hashbrown, and you're going to pick an AI provider of your choice. So, for example, if you wanted to use OpenAI, you would pick the OpenAI Hashbrown adapter, and that adapter is going to communicate directly with the AI provider. And in communicating with it, it's going to form really hardened streaming responses that we can deliver to your front-end web application. So in your front-end web application, that's where the majority of your Hashbrown implementation is going to be. And Hashbrown gives you a number of capabilities as part of its framework to build AI-powered applications. It gives you chat state management. All AI providers actually use chat underneath the hood for its generation phase. And so I'm going to call it out as chat state management, though certainly you would use it to build things well beyond just chat. It also has structured data capabilities, so you can get more than just text out of these LLMs. You can get really good structured data out of it. And perhaps most excitingly to me, it also provides a JavaScript runtime, allowing you to run LLM-generated code directly in the browser. And so using these three capabilities, which Brian and I are going to dive into in more depth, you then build AI-powered services and components directly in your Angular application. And since this is for Angular 20, all of Hashbrown is exposed using Angular's new signals reactivity primitive, along with the new resource interface. And so you really get to consume generative AI and generative user interfaces through this really great new reactivity layer that the Angular team has brought into it. So that's kind of the high level of Hashbrown. And let's just kind of dig into some code and see exactly what you can build with it. And I'm going to say that as we go through this, we're going to try and take you on a journey. We're going to start really, really small. This first use case is going to feel ultra tiny. And I think by the end of it, you're going to see that there's a lot that can be done with Hashbrown, probably a lot more than we've even imagined today. So kind of bear with us and let's start small.
Yeah, so in this first example, we're going to take a look at text completion. So if you've used an application like Gmail or something like that, where you start to actually type or compose an email, what's happening is the LLM is taking all the context of kind of what it knows about you, as well as what it knows about the current thread, maybe that you're replying to, and it's going to offer some textual suggestions around that. And in general, that's how LLMs are working. LLMs have this huge base of knowledge that they're trained on, and then they take that context and then they offer what they think is going to be the next set of like sequencing of characters or sequencing of wording that might be good to answer your question or to provide code or whatever that looks like. And so we wanted to take this very simple example to start with and look at how for Angular apps we can build in text auto-completion using LLMs.
Yeah. So I have a smart home app that I have written. This has all of the lights for the apartment that I'm in it. And it's just a sample application that I've written up in Angular. So you can see here's all the lights that are in my apartment. And then I also have a couple of scenes that let me control those lights. And if we take a look, you can see that I have in the living room, I have these entertainment ambient lights and an under couch light strip. Well, let's say that as a user, I'm trying to configure this application and I'm creating, all these different lights in the system. What would it be like if we helped accelerate them through that workflow using AI? So I'm going to go into add light here and I'm going to start typing in a name. Yeah, so as I start typing in, suggestions appear here. And note that like it's suggesting that I add light number 4. And this makes sense because if
Yeah.
I go to the data set, I already have 1, 2, and 3 here. And so it's not just providing a suggestion, but it's providing a suggestion that is aware of the application's context. So let's see how you'd build this with Hashbrown. So as I mentioned, Hashbrown is all built on top of the new resources API. And so to generate text-based completions, like the one that I just demonstrated, you would import from Hashbrown the completion resource function. And the first parameter you provide to the completion resource is the name of the model that you would like to use. As I said, we support models from OpenAI, Google's Gemini family, along with Writer. And if you wanted to use, for example, Gemini 2.5-Flash, you just apply that as the model name when you instantiate the resource. The next part of the completion resource, and I think is probably my favorite, is the system instruction. And the reason it's my favorite is because when you're using Hashbrown, so much of what you're going to do with Hashbrown isn't going to be TypeScript. It's actually going to be natural language instructions that you are going to give the AI to help it accomplish its task. So here I've picked my model, and now I'm telling the model what its task is going to be. I'm telling it that you're going to be helping the user generate a new light name based on their current input and the list of the existing names. And as the user starts typing in, go ahead and output sort of the next text segment that we would want to append to that to help them complete it. If the name is already finished or like looks like a good reason or finished name, just return an empty string to me. And so this is programming, but this is prompt engineering, right? And so we are writing up a prompt to the AI and giving it the instructions on how to complete its task.
Yeah, and so the next step here is to provide the actual input. And so what we're going to do next is the input option takes a signal, and we're going to use the computed function that comes right out of Angular to compute the value of that signal. And we're computing both the input value, so whatever the user has typed into that text box, along with the existing lights that are in my smart home. So we give it a little extra context, so that way it doesn't try to duplicate lights or something like that, like Mike said, as part of the system prompt. And this is all computed and provided to the model. So as those values are changing, we're going to recompute that and we're going to resend that request to the LLM, and the completion resource is the value is going to be updated as part of that. So we think it's really powerful that we're hooking directly into Angular's new reactive primitives using signals.
So that's really great for generating text, and it works for, like we said, doing some autocompletes inside of form inputs. But there's so much more that we think we could be doing with AI. And so building on top of this, AI, if it can generate text, well, then reasonably it could generate JSON. And if it could generate JSON, then we could have it, giving us or predicting actual structured data that we could consume inside of our Angular application. So Hashbrown as a framework gives you a set of tools to generate structured data from large language models. And to do that, instead of using a completion resource, you would instead use a structured completion resource. And just like before, the first thing you do when you use a structured completion resource is you give it the model that you want to use. So again, we're going to stick to Gemini 2.5 Flash. And then you're also, again, going to give it a system instruction. In addition to that system instruction, you're also going to give it an input, just like Brian mentioned. And this is all the same as the completion resource, but what you would need in addition to that is some way to give the LLM the structure of the data that you want to get out of it. So let me jump over to the demo real quick before I get into some more of the code so you can kind of see the experience that we're trying to build. So let's say that now I've kind of got my lights configured and I want to go create some scenes. Well, in a previous sort of version of this experience, if I wanted to go add a scene that maybe dimmed all the living room lights, I would have to go into this form and pick each of the lights, configure it one by one, and create this scene sort of manually, right? And that's because these forms exist to let users give us structured data. But with LLM, we have a real opportunity to instead let users give us natural language and then infer structured data from it. So I'm going to delete these. And instead of doing it sort of the manual way, I'm just going to give it a name. I'm going to say, let's call this dim living room to 30%. And what we're going to do is we're going to use the LLM to actually try and predict the lights that should exist in the scene based on the name alone. So you can see here that by calling this dim living room to 30%, it selected all the living room lights as suggestions for me, along with the correct brightness level. And now I can just quickly go in and add these to my form and hit add to create this scene.
Yeah, so you can think of structured completions as data in, data out. And so what Mike's going to show here next is that in order to do that, we have to provide the LLM with a schema. We have to tell the LLM that the response should be in a particular format or schema. And so Hashbrown ships with its own schema language. So kind of inspired by Zod, we have an LLM optimized schema language. This schema language is LLM optimized in that we require that you provide descriptions for all of the elements. And then we also narrow the scope of the schema to a very like subset because LLMs can't communicate in the way that like TypeScript can. So Zod's goal is to create a schema language that mirrors the capabilities of TypeScript. But that's just not how LLMs work today. And so we ship an LLM optimized schema language called Skillet. And so one of the things that comes right out of the box with Skillet is strict type safety. So you can see here that we've got the light ID and we set it to string. And Mike will show a demo here in a minute where we really ensure all the way through in your Angular components and your templates and everything that you get the type safety that you know and love and that you expect as a TypeScript developer. Like I also mentioned, it's very highly descriptive. So you'll see that here I have an array, and we're saying that this array are the lights that we want to add to the scene. And then for each object, this is a join between the light and the scene. And then for the light ID, it's the ID of the light and the brightness. And so we get this very nice descriptive schema language out of this. We also have really clear error messages. And so because we have our own LLM optimized schema language, we can optimize the errors that are shown both to the LLM as well as the errors that are come back to you as a developer. And finally, we have a streaming JSON parser. And a big shout out to Ben, who's actually here on the webinar with us, who did a lot of work on this. And we're going to show you exactly how this works here in a second.
So when you create the structured completion resource, you're given it the model, the system, the input, along with the schema. And as Brian mentioned, there are types inside of Skillet for all of the primitives inside of JSON. So you have helpers for creating strings and numbers and objects and arrays. But one of the things that we're really excited about is that, these LLMs, they take time to generate text. And as a developer, you sort of consume this as a streaming response. Well, Hashbrown does all the threading for you to bring or pipe that streaming response directly to your front end. And so as the LM is generating JSON that matches the schema that you provide, we're able to actually take advantage of Hashbrown's Skillet schema parse or schema language and its JSON parser to, let's say, proactively parse as much JSON
Eagerly.
as we can, or eagerly
Hmm.
as
Hmm.
much JSON as we can. And the way you do that is at any point in your schema, whether it be arrays, objects, or strings, you can just drop in the streaming keyword. And when you do that, you're informing Skillet that, hey, as the LLM has generated valid JSON for an individual element within this array, go ahead and emit it to me directly in my application. So if we go
Let's go
to,
back. Let's go back to the demo and show the difference there, Mike.
so if we go look at the code real quick, and I'll bring it over here. Let me run this example without the streaming keywords. That way we can see exactly what this looks like. So if I go into the add scene flow here now and I say dim living room to 30%, traditionally we would have to wait for all that JSON to be finished generated by the LLM before we display that response. And you could see that, right? Like if I go back and change this to 50, we
Yeah.
wait, and then we have all the suggestions and we show them all at once. But by using Skillet's streaming keyword and placing it on the array, we are telling Skillet that, hey, whenever an object has been generated that matches this schema, go ahead and emit it to me in my Angular template. So I'm going to hit save on this again, go hit add scene, dim living room to 30%. And now we can see that suggestions come in as fast as they are generated. And as the Angular developer, this is really easy to consume. Like I said, you were given this structured completion resource. And so to use this inside of your template, like it just ends up being a for loop, right? You get your predicted lights out. If we have some predicted lights, then we can just say for light of predicted lights and show a
Yeah.
nice color. We don't have to do anything special to try and consume this.
And you're getting that type safety and that IntelliSense all the way through. So, Mike, if you go back and like kind of highlight in even in the template there,
Yep.
we can see that because the schema we're using this LLM optimized schema, as Mike looks at this light, we can see that it has a light ID that's a string and a brightness, and that's all getting threaded through. And so you get this really good type safety as a developer, and it's really just the developer experience that we expect to get as TypeScript developers.
So that's what it takes to build structured completions with these LLMs. And speeding up forms is, I think, like a huge win here because I can't tell you how many really complicated form controls I've had to build in my career that were just designed
Hmm.
to let users input structured data. And so
Yeah.
the joy of Hashbrown here is that you can start to refactor your forms, strip out really complex controls, and replace them with simple natural language inputs that let the user communicate with you in whatever language that they speak, and then you get structured data back out of it by providing Hashbrown with that natural language and some application context.
I mean, Mike, just think about all the plumbing work that you've done in the past with Angular, with form groups and form arrays, and then you had to add validation and complex, and then showing things dynamically and adding certain dropdowns based on what the user has already chosen and dependence between the form inputs. And we have to plumb all that code in Angular. We have to write it, we have to test it, it all goes to production. And then our users also have to have this like cognitive load as they like enter into our form. And of course, many of us have gone through like a payment flow many, many times. And so we're very familiar with that. But a lot of times they might come to your application and they've never been through that particular flow. They have to like
Yeah,
figure it out and learn it. They get to the bottom, they click submit, and it's like, oh, I'm sorry, there's still something wrong. And they have to scroll back up and try to figure out what's wrong and where do I go? And there's just a lot of overhead there. And
yeah,
I mean, we're speaking in natural language right here, right? And like just it's so powerful to be able to take that natural language to our Angular apps and make them intelligent.
that's right. And I think it's not just like speeding users up through forms. I think it's speeding them up through entire workflows too. So we're going to take this same example, but let's build something different that's not really related to a form. Let's see what it would look like using Hashbrown to actually create predictions. So I'm going to go back to the application and I'm going to go, as you see here, I've kind of got these living room scenes. I've got one that sets my living room to a chill scene. I have one that turns them off, turns them on, and then I even have scenes that turn all the lights off for my nighttime routine. So kind of going back to that first example, let's say that I did actually want to go ahead and add that ambient light 4 here. Oh, I got one bad thing. It is AI after all. And if I hit add in a traditional web application, what the user would have to do is after they've created the light, they would have to go into each of those scenes and edit them and add that new
Mhm.
light to it.
It's a lot of
But we,
work.
the developer, know that they're going to have to do that. So like, why don't we just go ahead and use AI along with their action that they've taken to try and figure out what they want to do next? So I'm going to hit add light there. And you can see now that some suggestions have appeared or predictions that the user can either accept or dismiss as simple toast notifications. So you can see here that it's suggesting to the user, like, probably add this light to the living room chill scene with brightness of 40. That sounds great. I'll go ahead and do that. Why don't you add it to the off scene with brightness 0? Sure. And the on scene with brightness 100. Yes.
Mm.
And so I've saved the user of this application a tremendous amount of time just by trying to predict what their next steps are going to be. So let's jump into how this was built. And Brian, you want to tee this one up for me?
Yeah, so as the user's kind of creating these actions and taking these steps, wouldn't it be nice if we actually just knew about those actions? And if we're using something like a state management library that has actions at the core, and that we're using some good action hygiene, we can actually compose this quite easily using the last action. And so what Mike has here is he's got a signal called this.lastAction, and we're simply just getting the last action from the state management library. And then we're using untracked, and untracked is a function that comes from Angular. And what we're saying here is that we don't want to track these values. We only want to get them the first time. And we're getting all of the lights and all of the scenes in our smart home. And so every time the user actually takes an action, we're going to send this off to the LLM, and we're going to compute a new value using the structured completion resource. And you can see below that Mike has a really good system prompt. And if you go to hashbrown.dev, we've got some great documentation for you on how to write good system prompts. Mike's provided it with an overall description of what we're building here and how this is going to work. We've given some guidelines. Like we don't want the user to go out and try, like we don't want the LLM to suggest, oh, go buy new hardware or go do something outside of this application. And so we've built some guidelines as well as some rules. And this is really just kind of guiding the LLM towards that one shot, giving us that really good predictive output from the LLM. And the schema here is a streaming array. And so we're getting back an array of predictions and we're streaming those into our application. And if we go up to the schema language, we can see that the prediction schema is going to be modeled based on our state management library. And so we've got a type and we've got a name. The name is like suggesting the name of the scene as well as all the lights that are going to be associated with that. And so we've got all of these kind of predictions that are coming out of the LLM for adding a scene to the system, adding a light to the scene, all of these kinds of things. And so pretty quickly, using Hashbrown, using a structured completion resource, we're able to hook into the actions that the user is taking in the application, and then we can suggest follow-on tasks or actions that the user might want to take. And so we think there's a lot of power here in terms of enabling the user to kind of automate some of the tedious things that they might have to do normally in your application.
So hopefully following along this point that we're using the LLM to generate text, to generate structured data. So let's kind of keep building on top of this and take a look at chatbots. Because there's a lot of energy and excitement right now around building your own custom chatbots. I know that we have clients asking us to build chatbots. And the idea, with like MCP and these various technologies is that perhaps you want to provide your users with a chat experience to help them perform some kind of tasks or offer them support. And so, of course, using Hashbrown, you can absolutely build your own chatbot. So with Hashbrown, I'm going to quickly change over to the code. 1 second, I know it hasn't quite updated. Let's take a look at what this would look like. So inside of Hashbrown, you can build chat experiences like this. I'll say hello to the AI agent here, and it'll stream back a response. How can I help you today? And that's really great. Let me show you the code that's actually powering this. So in addition to a completion resource and a structured completion resource, Hashbrown comes with a chat resource. A chat resource, again, it's working fairly similarly. You give it the model that you want to use for the chat, along with a system instruction. And that's kind of all that it really takes to wire up a simple chat. You can also give it a debug name and tools. I'll talk about those in just a second. But to then consume the value of this chat resource, you can use simple chat.value. And then to send messages in response to the user, the simple chat resource exposes a send message method on it where you can send messages to the LLM. So as the user types and hits enter, we call send message. That prompts Hashbrown to reach out to the AI provider that you've chosen to generate a response to it. But it's like a chatbot to me has to actually be able to do something on the user's behalf. And Hashbrown provides you the ability to expose your Angular services to the LLM that it can call as part of its chat flow. So in addition to the model and the system instruction, you can give it an array of tools. And tools are pretty much what they sound like. It's like a toolbox. The LLM can choose to pull a tool out of that toolbox at any point in the conversation to help it achieve whatever the user has asked. So if the user's asked a question and it has a tool to get the answer, it's going to reach for that tool, run it, and provide that response back to the user. So you can see here that I have a tool called Get Lights. And this Get Lights tool is going to provide all the lights back to the LLM. And to do this, I give it a name. The name can be whatever you want to. It just needs to be unique within the array of tools. And then this description is really for the LLM. That way it knows exactly what the tool is going to do when it calls it. And then the final part is in Hashbrown, you give it a handler. And this can be asynchronous, so you can do sort of whatever asynchronous logic you want to do here. And it's also DI aware. So this all runs inside of Angular's dependency injection. That means that I can inject any Angular service I want to and call it inside the handler of this tool. So to provide the list of lights to the LLM, I'm injecting my smart home service, and then I'm just simply calling the load lights method on it. This is just literally returning an array of lights, like it's just structured data that I'm going to give to the LLM to help it answer its question. So with this in place, now I'll ask it, what lights are in the living room? And the LLM is going to call that tool, and then it's going to use that information to craft its response. So we can see here that it knew that the current lights in the living room are, and it's guessed this based on the way that these lights are named, the under the couch light strip, and then those 4 ambient lights that we just finished creating. Now, Hashbrown, when we're building it, we know that developers are going to want to understand, well, when did the LLM choose to call tools? How did it respond? What
Mhm.
was its flow as you're going through the chat? And so in addition to the model, the system, and the tools, you can give any resource in Hashbrown a debug name. So you can see here that I've given this debug name of simple chat. And what this does is with the debug name, I can use the Redux dev tools to actually introspect the state of the chat. So you can see here that I have the Redux dev tools open. If you've used NGRX or Redux, this should seem familiar to you. You don't have to know any of those state management libraries to be clear to use this. It's just that we're leveraging the same developer tools to let you introspect what's going on inside of your application. So I can go
And
into
I
the...
think
Go ahead, Brian.
I think it just makes a lot of sense to use the Redux dev tools. Maybe one day we'll have our own dev tools, but it makes a lot of sense because as the LLM is responding, this is all happening over time because it's streaming in these chunks of data. And so we can see as the data is actually being streamed in, and we can actually introspect all of the messages that the user is sending, that the assistant is responding with, and we can see all the tool calling that is being requested as well as the tool call response. And so Mike's going to show all of this here. So let's take a look at each of the messages and kind of go down through those.
Yeah. So we can see that I start off with the hello, and then the assistant responded back, hello, how can I help you today? The user then asked what lights are in the living room. And the assistant's first response, it didn't actually have any content. Instead, it called a tool. And the tool that it called was that get lights function that I just showed.
Mhm.
And Hashbrown then called your handler for you. And we can see that we succeeded. We fulfilled that tool call, and we provided the list of lights back to the LLM. The LLM then used that as context to create another message that actually responded to the user, letting them know what lights were in the application.
I think this is really powerful, Mike, because I mean, when you're debugging this as a developer, it's hard to know like exactly what's happening underneath the hood, right? And so this is a really powerful tool that I'm really enjoying to use as I build intelligent Angular applications. So I could pop open the Redux Dev tools. I'm already very familiar with them. I've used them before in the past, and now I can use this to introspect and see what's actually happening as the LLM is communicating back and forth with my application with Hashbrown.
Yep. So in addition to tools to read data, LLMs can actually take actions on behalf of your users. And so you can create tools that accept arguments. So let's say we wanted to let the LLM control lights in addition to being able to read the list of lights. Well, to do that, you'd use the create tool with args function inside of Hashbrown. Just as before, you give it a name. So I'm calling this one control light. And then you'd also give it a description that lets the LLM know exactly what this tool does. The thing that's different is now you're also going to give it the schema of the arguments that you want the LLM to generate as it calls this particular tool. So you can see that I'm asking the LLM to generate a control light input. And
Mhm.
this input, I'm going to need the ID of the light that the LLM wants to control, along with the brightness of the light that I want to set it at. Because this is using Skillet, all this is nice and strictly typed for me. So in my handler function now, I have one argument input. We can see here that we're going to get as an input to this handler, the light ID and the brightness of the light that the LLM wants me to control. So I'm going to inject my smart home service just like I did before. And I'm going to call the control light method on that smart home service to go ahead and control that light. I'm also injecting the global store for this application. So depending on the state management library of your choice, you might want to, let other components know that some state has changed. And so I'm using this as an opportunity to maybe dispatch an action or call some kind of method on that store instance. In this case, I'm dispatching an action, letting the application or some reducer somewhere know that the AI has controlled this light. So now I can go back into my application here and I'll say something like turn off the entertainment ambient lights. And it's going to use tool calling now to actually control those lights. And it turned all 4 of those lights off on behalf of the user. And we saw the application update in real time as a result of that, because we're using a state management library, and the LLM brought back a response to us. And if we
Yeah.
jump down, we can even see this inside of those same dev tools that we're looking at before.
Mhm. That's pretty
So
cool, Mike. But I really think it'd be great if we could get in and actually, instead of just showing text here, because right now we're just like communicating in text back and text forward. Man, it'd be a lot better if my chatbot could take advantage of the components that I've already authorized. And these components, like I trust these components, right? I've written them as an Angular developer. They're tested, they're compliant, whatever it is. Like I've got these components, I've got a rich set of components that I've already developed for my application. And what if I could take those same components and expose those to the LLM? And then inside of that chatbot experience, rather than just saying, hey, here, I did this with this slide or whatever it is, what if we actually started to expose those components so that way we could dynamically generate the UI inside of that chatbot experience?
yeah, so this is going to be something that you've probably never seen a chatbot do before. Maybe Open or ChatGPT does a little bit of this, but broadly, a lot of the chatbots that we see on the web are very static in that they're mostly just generating markdown, maybe sometimes images. Well, with Hashbrown, I hid something from you before. I had a simple demo flag set to true. I'm going to set this to false. And now instead of a chat resource, I'm going to be using a UI chat resource. And a UI chat resource differs from a regular chat resource in that the LLM is not generating text, but it is going to be, as Brian said, generating an entire user interface in response to the user every time. So just like before, I give it a model name. I can optionally give it a debug name if I need help debugging it and a system instruction. But in addition to these, now I'm also going to give it a list of components that I'm asking the LLM to use to create its response. To do that, you're going to expose components directly to the LLM. So you can see here, I'm exposing a markdown component. This is going to be what allows the LLM to show just regular text to the user if it wants to do
Hmm.
that. And I've just installed this markdown component from NPM using the ngx markdown package. And so I'm giving this markdown component to the LLM. I'm giving it a description to show markdown to the user. And then I also am going to tell the LLM how to bind data to these components, right? Because we're Angular developers, we write components with inputs and outputs. And so for the input of this markdown component, it accepts a data input.
Hmm.
That is sort of where I supply that markdown content. And because this is Hashbrown and we have access to Skillet, all of the schema for inputs are defined using Skillet. So you can see here that I'm actually going to bind a streaming string to the data input. This is all really well typed. Like if I misnamed this input, I would get an error because this isn't an actual input on that component. Similarly, if I tried using the wrong type here, I would get an error because it should be a string and not a number.
Nice.
And so using expose component, I'm giving the LLM the ability to render markdown. It knows how to show lights to the user, put lights in a list, and show scenes. And all of the interactions now using Hashbrown and this chat are all going to be done inside this component layer. So if I go back, let's do the same thing that I did before. What lights are in the living room? And this time it's going to use the tool and it's responding to me not with text, but with my actual Angular components streaming into me. These are the
But
real
Mike,
components. Like I
are those
can
real components? It's actual live components? Those are Angular components. Those aren't
thing,
just HTML.
they're really tied to it. I can,
Wow.
still turn off all of those lights
Yeah.
and turn them all off, and we'll see that the application was like all controlled, responds back to me. What
Yeah.
scene control those lights? Now it's going to go fetch the scenes, show those scenes to me, and I can control them. And
Mm.
like they're all like the real Angular components.
All being generated in the UI from the LLM, all because all I did is expose those components. So we use the expose component function, we bind that up into our resource, and now the LLM has this additional context of what the UI, what kind of UI it can draw, really, right? And then we use that to actually render out those components dynamically.
Yeah. And just to show that streaming again, like I said, that markdown component had that streaming
Hmm.
string as an input. So I'm going to ask it to write me a report about the state of my home. And so it's going to generate a UI now that uses that markdown information or that markdown component.
Hmm.
And you can see that it's streaming markdown directly into my Angular component, and I can
Nice.
render it and handle it however I want to.
Very cool.
Hopefully you're following along because now we're going to get into some really experimental territory with Hashbrown because with these large language models, We use it in ChatGPT to generate text. We've shown you that you can use, because it can generate text, it can obviously generate JSON, and so we can get structured data out of it. But as developers, we are often using these AI models to generate code. And so Hashbrown has this question of, what if we use the LLM to generate JavaScript on the fly and then ran that in the browser?
Wait, Mike, you're gonna run the code that the LLM generated in the browser? That seems like a terrible idea, dude.
Completely safe. Let me walk you through how this works. So Brian and I use AI tools on the daily to write code, and I'm going to tell you that no model is good at writing like full complex features or
It's true.
applications. No, it's not like that. The way that I think of it is that there's really good at commoditizing simple code. It's the boilerplate code or the glue code that's really easy to generate with these LLMs. And so those junior developer tasks of like writing simple CRUD or reg
Hmm.
expressions or test scaffolding, well, LLMs can handle those in seconds. Whereas like more complex features and things like that still needs to be authored by a human. And so with Hashbrown, we are using the LLMs to generate glue code, oftentimes, that we then go run in the browser. So what if we could do this? Well, Hashbrown comes with a JavaScript runtime, and this JavaScript runtime is based on the Quick.js library. It's a C-based JavaScript runtime that we have compiled to WebAssembly. And using this runtime, you can use Hashbrown to create it, and you simply tell Hashbrown where to load the WebAssembly in your application. Once you have that runtime, you can then provide it to maybe something like a tool JavaScript. So the idea here is that we are giving the LLM the ability to write and run JavaScript directly in the browser. So why would we do this? Well, let me start with a really simple use case. You see, large language models, they actually can't do math. They are prediction engines. They
Hmm.
given some data in, and then they try and predict what comes back out. They're intelligent, but they don't have the ability to like really run or know a mathematical result. And these
Hmm.
large language model providers like OpenAI and Google, they know that there's this deficiency or this defect inside of large language models. But
Yeah.
if you used ChatGPT enough and asked it some mathematical questions, you might have seen that it sometimes reaches for a Python VM, where to answer that math question, it writes a little bit of Python to compute the result and then provide that back to the user. And so we're taking full advantage of this with our JavaScript runtime and the fact that these models have been trained this way to let it write JavaScript to answer mathematical questions. So I'll ask it, what's the average brightness of the lights? And without a runtime, it wouldn't really be able to like get an actual answer to this. But you can see that it's running some scripts and it knows that the average brightness of my lights is 70. Well, let's go ahead and open up the Redux Dev Tools and see how it came to that conclusion. So if I dive into these messages here, you can see that I asked it what's the average brightness of the lights, and then it chose to run a tool. And the tool this
Hmm.
time was tool JavaScript. And it actually wrote a little bit of code that took the list of lights. And here I can even, well, I'll make this a little bit bigger so you can see it. I know it's kind of minified. But what it's done is it's taken the list of lights. And then if there are no lights, it knows to say there are no lights found, but then it takes the brightnesses of them, reduces them down, and then rounds it out. And the result of that, in this case, was an error. It had a syntax error. It did it again, got the right value. It succeeded
Hmm.
and got a result of 70. That's kind of one of the cool things. I'm kind of glad this appeared. This is one of the advantages of the way
Yeah.
it's done it. I only see
Yeah.
this happen occasionally, but if it sees a syntax error, the runtime actually surfaces those syntax errors to the LLM, giving it an opportunity to try it again. And so I'm not exactly sure what the syntax error was in that previous
Hmm.
code. Clearly, it saw that error, rewrote it, got it correct, and then we actually got back out a value of 70, which the assistant then used to confidently respond to the user that the brightness is 70. So that's really cool. That's great for doing math, but this runtime is potentially useful for more than just doing math. because in addition to telling Hashbrown how to, load the WebAssembly for the runtime, you can actually expose functions inside of this runtime that the LLM can call when it's writing scripts. So you might have noticed in the previous example that it was calling a getLights function. And the way that it's doing that is, as I said, you can give it a list of functions that are going to be exposed to it. And then using the define function inside of Hashbrown, you can create functions inside of this runtime. So I gave it a function called getLights, which the LLM was told it could use to get the current lights. And then what's different here is that I'm also going to supply what the return type is of this function using Skillet. The reason I give it a return type is that we're using Skillet this time to generate TypeScript annotations for all of these functions inside of the runtime. That way the LLM knows not just how to call the function, but also what kind of data it's going to get back out. That way it can be successful in actually writing a script against the functions you provided. And then from there, you just give it, again, a little asynchronous handler, just like with those tools. And I want to go back and note the async keyword here, because this is going to be kind of an important part of this. You see, with Hashbrown, we really want to let you provide functions inside of this runtime, but we don't want to make the LLM have to think about how to deal with
Asynchronicity.
asynchronicity. Like if it had to do async await and do async control flow, well, I can tell you from experience that it's going to have a harder time writing those scripts successfully. And so with Hashbrown, what we actually do is something clever called, or we apply an asynchrify transform to this runtime. And so all the functions you define can be asynchronous in your application code, but inside of the runtime, they're actually synchronous. So when the LLM writes a script, it has no idea that getLights is a async function. It's actually going to be given the result synchronously. So when it calls this, we're going to suspend the runtime, wait for your Angular code to produce the result. Once the result's ready, then we resume execution of the script, and the LLM just gets to write really simple, clean scripts against it.
And we saw that in the code that it wrote. If you go back to your demo, it was just const lights equals get lights. And so it didn't have to do any sort of async or promise.then or something like that. So it makes it a lot easier for the LM to actually write that code.
So let me show you how you might use this as one example. So inside of my runtime, I'm going to give it functions not just to get the lights, but also to add lights to the system, which is going to call my smart home service to create them, along with a function to create scenes. And so now in my chat, instead of asking it a math question, I'm going to give it a more complicated prompt. Let's say that in the guest bedroom, I've just bought some new smart lights and I want to add them to my smart home. So I want to add some new lights. I just added a standing lamp to the guest bedroom with a top, mid. I was looking at my shoulder to see which ones I actually have in there. Top, middle, and bottom bulb. I also have a desk lamp. Also create scenes to turn those lights on, off, and dimmed. And so normally as a UI developer, if I wanted to build a user interface that let the user create bulk things, this would be a really big chore to create. But because we have access to this JavaScript runtime and the LLM can write scripts within that runtime, you can see that it wrote a single script that generated all the lights based on that. We can see that they appeared here on the left, along with all the scenes to control these. These are real scenes, real lights, and it just worked using that runtime. And so you can build really complex workflows using this runtime and leveraging the fact that LLMs can generate code on the fly.
Mike, let's break out of the chatbot though. Let's go show a demo where we're not going to just have a chatbot. What if we could use the runtime to do something even more advanced? What if we could actually generate the entire UI of the application? And so we've got a next demo that we think is really exciting. And this is just exploratory, so bear with us. It's not like this is ready to go grab off the shelf and to put into your application. But in this next example, Mike has created a small financial application. And this financial application has some data around it. You might think of this as a demo that maybe you've seen on AG Grid's website or something like that, where it's hey, I got a product and I've got a bunch of revenue that's happening, and I've got some time series data for each of my products. And normally, what we would do as Angular developers is we would have all this data, and then we'd have to go and plumb a lot of code to both like orchestrate that data, to maybe summarize or to roll up that data. We'd have to wire this all up to a grid or to a chart. Let's say in this example, we're going to use chart.js. So now I got to go and I have to have the chart.js API. I have to like take all my data. I got to wire this up to the chart, and I just want to display charts to the user. So what would it be like if we actually took the power of natural language, if we took the power of exposing components through Angular? What if we compose that with our ability to run scripts in the browser using a runtime, and we just gave the user the power to generate the entire UI of the application?
Yep. So this demo is using chart.js along with Hashbrown to let the user essentially vibe code charts on demand. So I asked it to show me a line chart and it succeeded, but maybe I don't like some things about it. Put the legend at the bottom and change the title to product revenue. I'm going to go ahead and remix this as I go through it.
But just think about this, like as developers, if we were writing that before, we'd have to have like all this like, drop down, change the title, we'd have to have an input, we have to validate that, we have to store that off into state. We'd have to have like positionality of the legends in the top, bottom, right, or left. Is that valid? Does that go here? Does that go there? We have to store all this and persist it. We'd have to have UI to ask the user what they want to do and all of these kinds of things. Um, yeah, Mike, what if we do like a pie chart? Now, again, I'd have to like wire this all up to chat to chart.js. I'd have to, Mike's doing some aggregation here. So now I'd have to like write code to go and take all my data and summarize it, put it all together, create a chart, and do all of this. And we think it's really powerful to be able to take that natural language, bind that up to an Angular component, and really just start generating out the UI for the user. And imagine your users using a dashboard application where they're doing this. And previously we had to write tons of Plum code. Like we had to like wire everything up, get it all to work, validate it. We had to have forms and form groups and arrays and bring all this in and do all of these things. Oh, I like this vibrant color scheme. Yeah, that's a great idea, Mike. And you can see as Mike's running these demos, like it's just happening, right? The LLM is writing this code. We're executing this runtime in the JavaScript. Yeah, I like the red legend on the right, kind of squeeze things over. He's already summarized the data too. We saw before that our time series data was monthly based. And so now we're getting the volume of product by fiscal quarter. It's doing all that math for us. It's grounded and it's running that math all inside of the JavaScript runtime. So it's not hallucinating. We're not making up numbers here. Like everything is just working together seamlessly. And we've given the user an incredible amount of power to actually intelligently work with our Angular applications rather than having to tell them how to like figure it all out, right? Previously we had to really just like educate our users around navigational flow and capabilities and limitations and validation and all of this stuff. And we had to write all that code to make that all happen. And that was all well and good. But with LLMs and natural language, we can kind of break out of those barriers and break out of those limitations and start dreaming and thinking about what could we build with this? Now, this is just a small example that we think highlights some of the capabilities of using generative UI with Angular and Hashbrown.
So all the code that we just showed, both the smart app or the smart home app and the finance demo that we just showed, it's all in the Hashbrown repository. So if you want to go run any of this yourself, you're welcome to. It's all open source and available to you. So definitely go check it out. And that's Hashbrown. You can learn more. You can read the docs and get started at hashbrown.dev. It looks like we've got a few more minutes and we would love to answer any questions you have or dig into any of the code. But before we get into the questions, just kind of leave it with, using Hashbrown, what will you build? I'm excited to see the kinds of experiences that you're going to get to create.
All right, that was an exciting demo for sure. We do have one question in the chat, and then I actually have some for myself too. But Blair is asking, do you have an approach for automated testing, such as unit testing with these LLM-based outputs? And I think that just comes from us not trusting the models. They have great example. It says, could you test the question, what is the average brightness of the lights, and verify the result should actually be 70%? Oh, yeah, like 70, like how it was responding in the demo.
Yeah.
Do you want to take this one, Mike, or do you want me to?
I'll take it. So this is it's a great question. There's this kind of concept with AI engineering of evaluations. The
Hmm.
problem with LLMs is that they are non-deterministic. You're not guaranteed the same result. Every time I run this demo, it always is slightly different than the last time that I ran the demo.
Hmm.
And so actually guaranteeing that it's behaving the way you want to, you would typically not do it like with a traditional unit test approach because trying to apply a pass-fail mechanism to a non-deterministic system, it's not going to work out particularly well. Instead, you want to take what's called an evaluation approach, where you maybe write a
Hmm.
test case, but then you run it in number of times and verify that statistically it behaves correctly, like 90% of the
Yep.
time or 95% of the
Yep.
time. Hashbrown will have this built into it at some point. It does not have that today. We're at version 0.1. We anticipate that we will create a testing framework as part of this as we continue to mature out the library.
Yeah, and you can see how you might want to like even iterate on things like the system prompt, right? And you might want to measure that drifting. Like, hey, as we iterate off the system prompt, am I getting closer or farther away from kind of the desired output or to the desired path of the user? So there's some really good opportunities, I think, here to build some testing tools into Hashbrown, but it's not something that we have today.
uh, I think like Google search and everyone has solved for that problem about reliability by always having a disclaimer like, oh, the results are this is AI generated response may not be reliable, sort of a disclaimer. But I think everyone is yeah, it's just the world of LLMs that we live in. And so Jacob has another question. Says they work on a set of web apps for a very niche market, and they're wondering what it would take to provide guardrails or something like that to limit slash reduce the chances of LLM responding with incorrect information. So it kind of is a similar theme of what we were talking about earlier, the reliability of the responses
Yeah.
from these models, and they're asking if it's just a matter of providing the right tools and documentation.
Yeah, that's a really great question. And this one really depends on actually not just hash brown, but the model that you choose. So
It's true.
a lot of the models, or a lot of the like more advanced models we just showed you at the very end, we're using OpenAI's GPT 4.1 model.
Hmm.
And that's their newest kind of flagship general purpose model. It's not a reasoning model, but it's a like their flagship non-reasoning model. And it's really, really great at sticking to guardrails with very few sets of instructions. And I think, as LLM providers mature and get better, we're not going to have to really worry about this hallucination problem as much because they stick to those
Yeah.
guardrails. For less advanced models, the way that you do this, and we have a lot of documentation about this already around writing system instructions, is inside of the system instructions, you're going to give it those guardrails and it's often going to
Hmm.
adhere to them. Like
Yeah.
it's kind of funny to me, but like a really great trick in those system instructions is often to tell the LM like if you don't know something, just say you don't know. And like that'll clear up 90% of hallucinations, surprisingly. The other way that you
Yeah.
fix that or provide guardrails is with a technique called few shot prompting, where you provide in that system instruction a few examples of how it's meant to respond in those kinds of situations, often like showing the tool call orchestration that you'd like it to perform.
Hmm.
You don't have to write more than three of those, or like, 3 to 5 of those examples in the system prompt. That doesn't have to be exhaustive. It's just a few. But usually by providing just a few of those examples, it's going to be really, really consistent in following whatever particular tool call or component flow you wanted to follow. And then just real quick, there's a question, does Hashbrown only work with Angular version 20? Yes. As of
Yes.
now, since we were using the brand new resource interface, it only works with Angular 20. So hopefully it's not too hard to get to Angular 20. I don't think there was a lot of breaking changes in there. But yeah, that is a requirement at the moment.
Yeah, and well, I see Sean is asking if this presentation or something similar will be available for review later. I know we're
I
recording
think.
this, but I don't know if you're
Yeah,
sharing.
we're recording this. You can also go to hashbrown.dev, and we've got two videos right on the homepage today. The first one is just kind of a really short 2-minute video that Mike did just about like, here's some things you can do with Hashbrown. But if you scroll down towards the bottom, Mike recorded a 23-minute video where he's going to walk you through this entire demo as well. So if that's something you want to share internally with your organization or with your team, that's a great opportunity to kind of direct them to that video. They want to see like a good walkthrough of a lot of what we covered here today.
Yes, and Jan is asking if um, so no, no, will it be open source repo on GitHub? And I think by it
Yeah,
they assume they're talking about Hashbrown. I am assuming that. So yes, it
it's
is
all,
open source. It's on GitHub.
yep, yep,
I
it's all
shared the
there.
link.
Mike just dropped a
Oh
link
yeah,
in the chat.
yeah,
So yeah.
yeah.
Yeah, everything we showed you today is in that repository. It's all MIT licensed, 100% free. So grab
Mhm.
it, go show it to your boss, convince them to use Hashbrown, and then please let us know what your experience is with it.
Yep. And I think somebody has raised their hand, but I don't have the option to unmute them. So if you can come off mute, unless that was by accident.
I don't think I have that option either. Yeah, I see that raised hand. I guess you might have to put it in a
In the
voice or
chat.
and just put it in chat. Be happy to answer your question, Jared.
Yeah.
Oh no, he's coming in.
I
Okay.
just did it.
Thank you.
Thanks.
So yeah, Jared, you should be able to unmute your mic now and you can ask us a question if you'd like.
Or not. Yeah. Well, if you're not able to, you can always post it in the chat. Meanwhile, I was wondering, why would someone even spend time configuring the routes when whatever the purpose of the app is, like setting in the like the home light system, if I
Yeah.
can tell the chatbot to do everything what I want, like add lights, remove lights.
Mhm.
I can remove lights too, right?
Yeah.
Or like set up my themes and everything like that. Why would the app just not be a big chatbot? And why would I even want to have routes to go to and do it manually?
Yeah, you're asking like the really big question that Hashbrown's asking, which is the way that we use
Mm.
apps today is I have some task I'm trying to do, and routing and navigation lets me as the user figure out where to go to make that happen. But with generative user interfaces, we have a real opportunity to just completely break all those conventions, right? Like I can
Yeah.
actually just ask the app the question and it can respond to me. I don't have to think about how to move around the app, how to get to where I'm going, and how to use it. I can just ask and it can respond. And I suspect that is exactly where this is going. I think that over the next couple of years, more and more applications are going to be generative user interfaces rather than traditional structured.
Mhm.
Instead of moving around and navigating and using menus, we'll just speak or talk with the applications.
Yeah,
You know,
exactly.
it's
That's also what I was gonna ask. Like, have you tried a voiceover commands instead of typing?
Yeah. So to these LLMs, they have modalities, and today Hashburn only supports the text modality. We have full intention of supporting voice and video modalities for
Mhm.
Hashbrown, so that in the future you could build Angular apps that don't
Mhm.
just know how to generate text, but can speak and that you can talk to them and can see the world around you. And we have a lot of exciting things that we want to go build with that capability. So stay tuned. Stay involved in the Hashbrown project. Follow us on all the social
Sure.
media. Come to the ng-conf in the fall, and I'm sure we'll have more to share
Definitely.
about other modalities by then.
Yes, absolutely.
Yeah, I
You
think,
can attend a full-fledged workshop in person at ng-conf happening this fall.
yeah,
Sorry,
I think
Brian, were you gonna say something?
Yeah, I think the other thing that like we really haven't touched on, which I think is also very interesting, in this concept of like structured UIs and the navigation, and we've talked a lot about forms and some of the overhead there, both in terms of the user overhead as well as the developer overhead. We didn't even touch on the accessibility part of all of this. Because if you think about just the way we build a lot of applications today, they're not really all that accessible in terms of accessibility tools, but also just like for users maybe that are really challenging to use a web app. Like they got to really figure out things and try to understand things. And sure, I think we do a really good job of like working with designers. We try to figure out like optimal navigational flows and how to simplify things and all of that. But I wonder as we continue to break out of these constraints and these limitations, if our applications become really just more natural, more accessible applications for users to use, whether that's for us or for people all across the spectrum. Um, and of course, we didn't even talk about like multilingual support. Like Mike can go back into that demo, and like we haven't done. You saw all the code for that demo. You can go clone out the repo. Like we don't have a lick of other languages in that demo. But if you're speaking Hindi or Marathi or Spanish or German or whatever it is, like Mike could go to translate.google.com and say, "Hey, give me, what is your lights in German, which I could try to take a stab at, and I would probably do terrible at. But like, it'll just figure that out and respond. Like the accessibility, the internationalization, the localization of all of these applications, just like things just start to explode. And I think our minds are just wondering, like, what is this all going to look like in terms of how we actually build applications in the future that are intelligent and that are really built with high accessibility and high standards around, IET9 and all of these things. And so, I think the call to action here at the end is like, what will you build? And honestly, we're truly curious. Like, take Hashbrown, go out there, build something, ask your boss for like a day or two, go build something really cool, show it to them, get a raise, go help your organization actually like explode into this new world of building like Angular apps. And I think that this will also start to diminish some of the fear around AI and software development in the future. And so there's a huge opportunity for us to go out and build really powerful, incredible applications using LLMs and using tools like Hashbrown.
Yeah, I'll show a quick demo of what Brian was mentioning. Like my fiance, she is Maharashtrian, and so I've tried to learn a little bit of Marathi from her over the past couple of years, getting to know her. And so if I asked in Marathi, what are the lights in the living room, for example, like I didn't have to do anything special, but it knew how to respond and answer that question in that language. And like that's to me, that's just a
How
really
it
exciting,
happens. It's
yeah,
so
part
powerful.
of generative UI.
That's amazing because I know setting up translations and internalization and
Yeah.
localization is such a big hassle. Not just like it doesn't even depend on what framework you're using. It just is a lot of work as a developer to
Yeah.
have that support for your app. And so if it's all built in, configured, that is really great. I just have one more question.
Sure.
So you showed us an example of how you can mark down and other components that you can add on to, and then it shows up. Can you specify directories or can you specify a block list of components like, hey, us apart from these components, show leverage all the other components that I have in my, I don't know, like a UI kit directory and roll with it.
Yeah, there's nothing really built into Hashbrown yet for that. I think one of the things that we're trying to figure out is what are the limitations here. I think in our
Hmm.
testing, it has maybe a ceiling of maybe like 50 components, 50 tools. And so at the moment, with that limitation, we think that the best approach is to probably have the developer be really explicit about which ones the LLM can actually access or generate at any given time. But as those
Hmm.
limits disappear and LLMs get even more and more capable, I think there's a good chance that we'll just be writing components in a way that the LLM can pick up and generate any of them on the fly.
Yeah.
Um, yeah.
Yeah, that would be super awesome. And I see one more question from Habasi, if I'm saying the name right. Is it possible to integrate Cloud AI? I know you demoed it
Well,
with Gemini and
Yeah.
ChatGPT, but I assume it's the same.
Yeah, so we have built-in support for four providers essentially: Google, OpenAI, Writer, and Azure. And like the code for these are really, really small. Like I don't mind actually just showing how small these tend to be. Like this is all the code that it takes to have gotten Azure to speak to Hashbrown. It's about 165 lines of code. And so while we don't have support for Claude built in or Anthropic built in, it would not take you much as a developer to probably add Anthropic support if you wanted to do that. And if we get enough people asking us for Anthropic support, we will gladly go add an Anthropic package directly into Hashbrown.
Go ahead, Ryan.
uh, sorry. The other question that we also get is like, are we going to support things like Window.ai and some of the like local AI LLMs? And so that's something that we're also exploring as well. So kind of stay tuned on that. But yeah, we think it's pretty easy to explore some of that and start learning and kind of go from there. But we are seeing that, you know, GPT and Gemini are certainly very capable models, and they're able to work very well with this. And so we get really good outputs from those models.
That's awesome. And also, it's all open source. So if you feel like trying something, that's the easiest way to do it. Just fork it, try it out, and maybe you submit a PR about it supporting other models.
Yeah.
Um, together rebuild better. So I'm not seeing any more questions come in through the chat, but I know Mike and O'Brien are very easy to reach. I don't think you all shared your socials or what would be the best way
Yeah, so you can find me
if someone has questions.
Mike Ryan Dev, and then Brian, you're Brian F. Love, right? Or B Love. You're B Love, aren't you? You're B Love. On
I'm
GitHub?
Blue Sky. I'm Blue Sky on blove.dev. On GitHub, I'm blove, and then on X, I'm Brian_love. So I'll drop those in the chat.
And then also I just want to shout out that there is the Angular community meetup tonight. And at the Angular community meetup, we're going to do a 1 hour Hashbrown workshop. So it's not going to be the same content today. We're actually going to do a little hands-on workshop showing you how to build a UI chatbot of your own. So if you want
Mhm.
to like come learn how to build Hashbrown, you can join us this evening and we'll do that.
Nice.
All right. Last opportunity to ask questions, I guess. Well, I guess everyone's just really appreciative of this. It's great work. I'm sure you guys are proud of this. I don't think there's anything out there like this yet. So
Nothing like
Cool.
this. Not in Angular or React. And so
yeah,
we're really excited to bring this.
that's another thing. We don't see a whole lot of things like these that are Angular first. So that's also super exciting.
Yeah. We love the Angular community, so of course we had to be Angular first.
All right, everyone. Thank you so much for joining and spending time with us and learning and exploring Hashbrown.
All
Thank
right,
you.
thanks, y'all. Peace.
See ya.